Last time we started section 2.1, reasoning and logic. We talked a little bit about something called truth tables, and we had encountered 3 different types of truth tables. The first one was a very simple negation, right? If something's true, it's negation, it's false. We also encountered conjunctions. Those are ones with the and statement. Those are only true if both individual statements are true. And we encountered or statements or disjunctions, and those are true anytime either piece of the of the 2 statements is true. So today we're going to continue in our discussion of truth tables with a truth table that's got a combination of things. All right, so as you're taking a look at a truth table for P, the upside down V means and, P and tilde Q, you will always start the same way. Do you remember what your first 2 columns will always be? P and Q. So no matter what's in the individual piece, even if, like right now in this one, there's actually not a Q all alone by itself in your compound statement, you're still going to have a column for it. So you're always going to have the column PQ. 1P, 1Q. Now, if you look at the individual pieces now, P is already in there. We have Q, but we actually need tilde Q. So I'm going to do a column for tilde Q next. And now I have all of the individual pieces like alone. So I need a column that represents all of it combined together. So the compound statement P and tilde Q. That will be our last column in our truth table. So I can't tell you how many columns there will always be. That will change depending on what the pieces are of the, the information you were given. But the first 2 columns will always be the same. The true-false pattern in the first 2 columns is also always going to be the same. What will the P column look like? Right, 2 trues followed by 2 falses. And then what will the Q column look like? True, false, true, false. They alternate. True, false, true, false. And remember, we went through why that gets all of our combinations of possibilities, so I won't do that again, but it does take care of them. Now, if I'm moving to the tilde Q column, it means that I'm reflecting back upon which column? The Q column. So I'm looking at this column right here to make my judgments about the tilde Q column, okay? So on the first one, Q is true, so tilde Q would be false. And then when Q is false, tilde Q would be true. And we have the same thing continuing, so it's false, true on the last 2 as well. Just alternates whatever Q was. All right, so our last piece of information then is what will happen when we combine the individual pieces that are in the compound statement at the end. So we need the P column and we need the tilde Q column. So we're going to use those 2 pieces of information. And this tells us right here that we have what kind of a statement again? And statement, conjunction. When is an and statement true? When they're both true. So let's look at what we have. Actually, I'll leave that there. On the first row, I have true and I have false. And I'm using the yellow pieces, right? True in the first column, false in the third column. So if I have 1 true and 1 false, the compound and statement would be false. The second row, I have a true statement in the first column and a true statement in the third column, which would give me a true statement. The third row, I have a false statement and a false statement, which gives me a false statement. And the fourth row, I have a false statement and a true statement, which gives me a false statement. Okay? So hopefully you can see that if you mess up, early on, like one piece is off at the beginning, it might, depending on whether you have ands and ors and so forth, affect your final result as well. Because these things builds on itself, right? So it's, be very careful as you're doing them so that you don't mess up early on to mess up the result as well. All right, so a little bit of vocabulary. We're going to do one more kind of truth table, but it's in just a little bit. Logically equivalent. 2 statements are logically equivalent if they have the same truth value in every possible situation. Okay? So, for instance, if I had another statement, and at the end it said false, true, false, false. The last column, false, true, false, false, was exactly the same. Then those 2 individual compound statements, that one and whatever else that was that gave me that false, true, false, false, would be logically equivalent. Okay? They give you the same final column. De Morgan's laws actually tells us about two types of statements that are logically equivalent. And I don't have a tool, unfortunately, that does this, but these actually should have like 3 lines here. That's actually what it needs to look like for it to be logically equivalent. Oh, I didn't write that up here. I'm sorry. It's supposed to be here as well, the 3 statements right there. 2 statements are logically equivalent. Means they have 3 lines in between, and that's the notation. Sorry about that. All right, so let's talk through De Morgan's laws, fill them in, and then we'll chat. We're going to do the first one. Notice just where P and Q are, okay? So the P and the Q in the parentheses on the left, and if I have a negation in front of them, what happens when the negation sort of transfers through the argument to the P and the Q? What happens to P? It becomes negative P or negation of P, right? And what happens to the Q? It becomes the negation of Q, all right? So each individual statement gets negated. Look what happens to the symbol in between them, though. What do you see? It becomes the opposite, right? So if it was an and statement to begin with, it becomes an or statement when I do the negation. In some sense, you almost feel like that you're negating each and every piece, and there's 3 pieces. I negate P to be tilde P, I negate Q to be tilde Q, and I negate and to be or. And it works in either case, so it's the same thing on the second one as well, right? P becomes tilde P, Q becomes tilde Q, but or becomes and. Now, we'll do an actual compound statement so you can see how it makes sense and that it fleshes itself out here in a second. First, we're just going to work with the symbols. So if we have this statement right here, tilde, and then we have in parentheses P and tilde Q, we're going to write the negation. I'm sorry, I was reading the wrong one. On 3, P and tilde Q. We're going to write the negation of P and tilde Q. In other words, what we want to do is we want to take this, we want to put a tilde in front of it, and find out what happens when we move the negation through the statement. Kind of feels a little bit like we're using something called distribution. It's not really, but it has a lot of the same attributes. So what's going to happen? What am I going to get?
Quick question.
Yes, ma'am.
Why did you put the tilde in front of the P, if that's what it wasn't originally up there?
I put the tilde in front of everything. Do you see how it's in parentheses?
Oh.
Yeah, it's in front of all of this. Our goal is to negate the entire thing.
Okay.
So the entire thing is P and tilde Q, and I want to negate all of that.
Because it's not in the example. Like when it's,
Right, it says negation.
okay.
The word is.
Yeah, I know. I just thought, okay.
Are you talking about example 3 or example 4?
Example 3.
Okay, yeah, we're doing this. It says use De Morgan's laws to write it. So that's what we're doing. We're writing it. We're putting the negation on the outside because that's writing negation of. And then our other side is going to be just distribute it through. So if I am negating the whole statement P and tilde Q, what am I going to get? Okay, I'm going to get a tilde P, and then I'm going to get an or, and then I'm going to get a Q. So the result, if you will, Ariel, oh, I'm sorry, that didn't mean what I was to do, is that this is the question, what is the negation of, da-da-da-da, and over here on the right, this is our answer. So our answer to the question is tilde P or Q. Now, what we're going to do on number 4 is we're going to show that if you try to do everything with a truth table with what's on the left, or if you try to do everything in a truth table with what's on the right, you actually do get logically equivalent statements. That is, you're going to get the same trues and falses at the very end. So we're going to create 2 truth tables, okay? One of our truth tables is going to be the left-hand side of this statement, and the other truth table is going to be the right-hand side of this statement. So my first truth table, well, both truth tables, I should say, to start with, start out the same, right? How does a truth table start out? You got it, a P column and a Q column. And what else do I have in my P and Q on the first one? Well, before that, I'm sorry. I'm just going to label my column headers first. A tilde Q. And what else do I have? Right, P and tilde Q. And I get this feeling like we've done that. Have we done that already? We have. So if you flip back on one page on your notes, we already did this truth table. This is what it was. So you can either just transcribe it over, or you can go, back through all of it again. But this is the truth table that we got. True, true, false, false, so on down the road. So my truth table went true, true, false, false, true, false, true, false, false, true, false, true, and then it was false, true, false, false. We did it before, so I'm not going to belabor the point again, but we already did that one. So this is half of the argument from example 3. We did the left-hand side. I'm going to label it as number 2. We're going to do the right-hand side now. Now, we know we're going to have a column for P and Q, right? Everybody's good with that now, yeah? Looking at that statement, what else are we going to have columns for? Okay, so tilde P, and then the final compound statement of all of it, which is tilde P or Q, right? Okay, so what does P column look like? True, true, false, false. What's the Q column look like? True, false, good. Okay, so we haven't done a tilde P column. We've done a tilde Q column, but what do you suppose we're going to do for tilde P? Right, we're going to take everything from the P column and reverse it. So it's going to say false, false, true, true. And then my last column needs to compare tilde P, which is this column, with Q, which is this column. And is it an and statement or an or statement? Or. And when is an or statement true? If at least one of them is true. Okay? So using the pink highlighted columns, the first row says true, false. That would be true. Did I screw something up from before over here? Oh. No, I think it's okay. Okay. There should be. I'm trying to figure out what I did wrong. Oh, okay, let's just fill it in and we'll see if I can figure out what my notes are messed up on. Okay, second column says what? False, false, so that would be false. The third column says true, and the last column says it would be true. Okay, we missed a column on our first table. That's how long it took me to figure out what's wrong with me. Okay, let me shrink it just a little bit. Does anybody know what the column is that I'm missing on my first table? Look back at what the first number 1 said. No, not tilde P. I'm supposed to be doing all of this. What's missing? The tilde in front of all the parentheses. I need a column for that. Do you see that tilde right there at the beginning right here? I didn't do a column for what happens when I put the tilde on the outside of everything, and I should have had one more for that. If you think about like order of operations where you're moving from the inside of the parentheses to the outside of the parentheses, I just never moved to the farthest outside of the parentheses. All right, so I need one more column over here, which is tilde for the P and tilde Q. So I'm taking the column, let me use a little bit different color. The column right here, and what am I supposed to be doing in that final column? Doing the opposite of that column. I'm supposed to be negating that column. So on the first row where it says false, I should be getting a true. The second row says true, I'm getting false. The third row says false, so it's true, and the same thing for the fourth column. So what do you notice? There we go. These two are the same when we're done. They match. So if I did the left-hand side of the equation, if you will, that I had on number 3, I know I've got marks everywhere and it's kind of a mess. One that's labeled number 1. And if I do the right-hand side of the equation for number 3, labeled 2, I get the exact same truth column at the very end, which means the statements are logically equivalent. Now, I told you I was going to do a concrete example, and that's the next one. Here is a compound statement. It's got the word "and" in the middle. Somebody says to you, "It is not sunny and I will go for a walk." Now, I mentioned last time that negations are tricky in a couple of situations. Some negations are easy. All we have to do is put the word "not" in there. I ate eggs for breakfast. I did not eat eggs for breakfast. The kind we encountered last time that are tricky to do negations for are ones that say all, none, some, there exists, those quantifier statements. The other one that's tricky to do negations for are compound statements, things that have and or in them. So this is one of those. It's a compound statement, a conjunction. It has and in the middle of it. And we're going to use De Morgan's laws to actually change this statement. So there are 3 parts to this compound statement. There's the first statement, there's the connective in the middle, and then there's the second statement. And De Morgan's law says I need to change all 3 pieces of that to create the negation. Okay? So what is the negation for "it is not sunny"? Yeah, that part's pretty straightforward. It is sunny, just like today outside. It's so pretty. And that will be an or. I will tell you that when we get to an exam, half of you are not going to remember to do that piece. That's the most commonly forgotten piece, is to change ands to ors and vice versa. Last piece, I will go for a walk. I will not go for a walk. Now let's actually just read those 2 statements together and see that it does in fact make sense when we talk about it being a negation. The first statement says, "It is not sunny and I will go for a walk." If it helps you to think of it as not sunny as cloudy, you know, an opposite of it in your mind, that's the idea. So it's cloudy outside and I'm going for a walk. The only thing that it takes for one of those 2 statements to be true is for either of them individually to be false, right? If either statement's individually false, the whole thing's false. So the first statement being false would be that it is sunny instead of it is not sunny. The second statement being false is that I won't go for a walk when I would have gone for a walk. And I only need one of those to be true, so I put the word "or" between to indicate that either of those things could happen and the first statement would be wiped out completely. Make sense? Right? All it takes for Dr. Whitlock to walk in here and to be able to say, "I'm a female" or "I teach math" is for him to start teaching math. That's all it takes, right? Just one of those 2 statements being false would do it for us. All right, we have one more type of compound statement, and they're called conditionals. Conditionals are statements that are expressed in the form of if, then. They're also sometimes read P implies Q, and they are written with an arrow between them, P arrow Q. The hypothesis would be the if part of the conditional. The conclusion would be the then part of the conditional. And, I'm sorry, was anybody still writing? My apologies. The space that's at the bottom of your paper, leave it on there. If you have flipped your page, flip it back. We're going to write the conditional truth table next, okay? So your space is there. All right, everybody good? All right. So just like with any other statement, you're going to have a P column and a Q column, so start with that. And our final column for this conditional statement will be the combined conditional, P arrow Q. We're going to fill it all in, and then I'm going to explain why it is what it is, okay? So you know how to fill in your P's and Q's, so go ahead and do that. All right, so again, we're just going to write them down, and then we're going to chat. In a truth table for a conditional, true implies true is true. True implies false is false. False implies true is actually true, and false implies false is also true. Just fill it in, and we're going to do an example. Have it written down? No. P is going to be the statement, I am a mom. And Q is going to be the statement, I am a woman. Okay, the first column, or the first row rather, you're probably going to be like, yeah, well, obviously that would work. Get that. True, true, true. Everything that's got two trues is true. Worked for ands, worked for ors, works for if-thens. Great. If I'm a mom, then I am a woman. And we all say, yeah, right? You're talking with someone on the phone and they say, I'm a mom. Even if you have a nondescript voice where they can't tell if you're a man or a woman, they're going to know because you said you were a mom that you're a woman, correct? Absolutely. Okay? Second one. I'm a mom, then I am not a woman. And you'd say, no, doesn't work that way. So you're probably pretty okay with my second row being false, right? I can't say if I'm a mom, then I'm a woman. I'm sorry, I said it wrong. If I'm a mom, then I'm not a woman. That doesn't work. So the second statement being false is for sure a good deal. It's the last two columns that trip people up. All right, so this is again the nondescript voice on the phone. And you ask them, are you a mom? And they say, no, I am not a mom. And they say, but I'm a woman. And you would say, okay, I mean, that's possible, right? I think that's probably most of you in here, right? Okay. Or you say, are you a mom? And they say, no, I'm not a mom. I'm not a woman. And you'd say, okay, that's totally possible. So that's a true statement as well. Okay, so either of those statements at the end could be true. It's the benefit of the doubt. We're not owing to, basically we're asking ourselves, could I for sure accuse them of lying to me? And you could not for sure accuse either of those last two people of lying to you, right? You don't know. So you're going to give them the benefit of the doubt, and these statements could, and in fact we say would be true. All right? Now, for the purposes of simply remembering which is which and so forth, the easiest thing to remember is to remember the one that doesn't work out to being true. The only way that a conditional is false is if it's true and then false. A true statement as a hypothesis, false statement as a conclusion is the only way you get a false conditional. So if you're just looking for like, how do I remember which is which, that's the easiest one to remember. It's the oddball. All right, so we're going to do a couple of examples with this, and then we have one more piece before we move into group work. We're going to let P be the statement, you build it, and Q be the statement, they will come. And we're going to pause for a moment and see if anybody knows what that's from. Did anybody else know? It's becoming more and more obsolete every year I use it. This is from a movie called Field of Dreams. Kevin Costner, right? I'm pretty sure. You should see it. It's very interesting. It's a good movie. It's about a guy building a baseball field in the middle of a cornfield, like in the middle of nowhere. And the result of what happens, it's really good. I actually encourage you to watch it. You'll enjoy it. All right, so these are what we have for our individual statements. P is you build it, and Q is they will come. And we're going to write the statements out that they give us in sort of verbal form, and we're going to write them in symbolic form. So here's the catch. The first thing you need to figure out is where the if is. So where is if in this statement? If you build it, right? This is the if part. So even if it occurs at the end of the statement, that's where you have to start when you're writing out your symbols. If what? If you build it, and you build it is the symbol P. So we are going to start with P, and while it's not written in here, there is an understood then, right? Then they will come. So this would be P, arrow, Q. It is logically equivalent when we say it in English to say, they will come if you build it, or if you build it, they will come. It's exactly the same statement. We turn that around all the time. I cannot imagine that every language does that. And so I suspect for our non-native English, I should ask my teenagers and see if that's weird for them. I really don't know, but I don't think that's true for every language. Okay? So you got to identify where the if is first. All right, on the second one, the if is actually at the beginning this time, right? So we're going to start at the beginning. It says, if you do not build it. So what will that look like in symbols? Tilde P. Good job. And then we've got our arrow. It says, then they will not come. That would be tilde Q. Okay. Now what we're going to do is we're going to do this exact process in reverse. We're given symbols, and we're going to write out the verbal language associated with it. P and Q have changed meaning, so let's read those together. It says, P be the statement, God loves me, and Q be the statement, I am a sinner. All right, so what will I write for my first P and Q if I'm writing out the language associated with it? God loves me, because that's P. The symbol in between there is the word and, so you guys got that, that was good. And I am a sinner. And as Christians, we believe that statement, right? God loves me and I'm a sinner. All right, our next statement starts out with tilde P. So catch this. You see how this one has an arrow? This one didn't have an arrow, right? So I didn't have to worry about it. But once I see an arrow, how is my statement going to start? If. Good job. So we must start with if. I know the arrow is in the middle, but if comes at the beginning. Usually when we're writing it out, it's easier to write it that way. If what? So what is tilde P? If God does not love me. What would come next? Then I am a sinner. And truth be told, if somebody said that to us, you would say, well, that sentence doesn't even make any sense because God doesn't not love you, right? It doesn't even make sense to make this statement at all because the first part is automatically false. You with me? Okay. All right. Last thing we're going to do today is we're going to look at some specific types of statements related to conditionals. Okay, so I'm going to write down the symbols for it, all right? We're going to talk about how the symbols work, and then we're going to do an example of a statement where we're going to find the pieces. So your statement first with a conditional in symbols is P arrow Q. Okay, if P then Q. What a converse does is it switches the order around. The P's and the Q's switch places, so we have Q, arrow, P. That's called the converse of a statement. So on the one I had before, if it starts out, if you build it, they will come. If I switch the order, it was, if they come, you will build it. Okay, that's what it would mean, literally, to switch the order. And inverse doesn't switch the order, but it negates each of the individual pieces. So this is tilde P, arrow, tilde Q. Now, people do this all the time. They'll say something like, if you build it, they will come. If you do not build it, then they will not come. You're going to explore whether or not those two statements actually mean the same thing in your group work. Our last one is a contrapositive, and a contrapositive not only switches the order, but it switches the order and it negates them. So it kind of does like both of what the inverse and the converse do. So we have tilde Q, arrow, tilde P. Yes, ma'am.
Is if always with the P?
Nope, if is always with what comes before the arrow.
Okay.
Yeah, it always starts out with the if part from before the arrow. So on this one, with my you build it, they will come, just a second, Zion, it would be if you do not build, I'm sorry, if they do not come, because that was what Q was, if they do not come, then you do not build it. That's what it would be for that one. Yes, ma'am.
Okay, so the one in example 6 where the if was later on, you still
Yes.
put the P at the beginning even though the if was later.
Correct. Exactly. So even though in English we turn around the statement sometimes, the if still is understood to be what happens first, right? I mean, I can say they will come if you build it, but you necessarily know that the starting point of this, the origin of what we must do, is the part that says the building it part. Yeah. Okay, I've got something to show you real quick before we do our example. All right, so we hear logic like the song Silly Songs with Larry all the time from people, and you'll probably now pick up on something over the weekend and you'll be like, oh, yeah, that wasn't quite right. So we're going to write this one down here for if I'm a monkey, then I have a tail. So we're going to write or create the converse, the inverse, and the contrapositive, okay? So we have our original statement. So if you're sort of like lining this up, this is the original given statement. And we're going to start with the converse. So what did the converse do when you're comparing it to the original statement? It flips the order. So we're going to keep the if at the beginning. You do not move the if as you're doing this. If stays at the beginning, okay? So all the statements are going to start out if. But if I change the order of the statement parts, what would come next? If I have a tail, then I am a monkey. And we saw that was a problem with the video, right? We see the cow, he has a tail. It's not a monkey, even though Larry says it is, right? Not a problem. I mean, that's a problem. That doesn't work. All right, so let's try inverse then. All right, inverse then. So what does the inverse do? First we write if. Always writing if first. What am I going to change on this one? Right. You got it. So if I am not a monkey, then I do not, again, there's that not, have a tail. Okay, the cow is another example of this statement not working, right? The cow is not a monkey. However, he does in fact have the tail that it says he's not supposed to at the end of the statement. Our last one is a contrapositive. So what does a contrapositive do besides starting out with the word if? Negative and flips it. So if I do not have a tail, then I am not a monkey. And that sounds a lot like the first statement, doesn't it? It does. So you'll explore some more with your group work about these comments.